Okay, so now that I gave you that second part of notes that could help you with the first two questions on this homework assignment, on this piecewise functions homework assignment, I'm going to record number 3. And the reason why I want to record number 3 is so that you can see exactly how not only to solve this by hand, but also how you can check with both a calculator and you can check with Desmos. Okay? Again, I'll reiterate, Desmos is not going to be used in class. On tests and quizzes, we will use the TI Inspire only. But also, I want to reiterate that Desmos is not to replace the learning, but just to check and give you feedback when you're home and you're doing these by hand. All right, so let's begin. Number 3. So I have 3 pieces right here. Okay, so I'm going to put a huge brace because I'm going to have 3 separate functions for these 3 pieces and 3 separate domains. Okay, so before I begin, let me put an arrow on the graph because nothing's there shows that it's going to go on forever, just like it would on number 4, there and there. Okay. Now, I find it probably easier to do the domains first and then to go to the graph. You can do either way, but I want to list the domains first. So the domain of this first piece, let's highlight what piece we're talking about. We're talking about this piece right here, okay? Let me highlight it a little bit better. We're going to look at the domain, and we're going to see that there's an open dot at x equals -1, and it goes to the left, and it stops at -5. Okay, so there's a closed at 5, and then only that piece is graphed. We're talking about domain. All the x's from -1 all the way to -5, including -5, are going to be shown in this graph. So what I'm going to do is, for my first function that I want to list, and I usually list these, the most left graph, the next one, the next one. So it's like you're reading from left to right, and you're listing them from top to bottom, like that. Okay. So the domain that we just showed is going to be starting at -5 less than or equal to x because it's domain, and then less than -1 because it's not hitting -1. It's an open dot at -1. That's why we're just putting less than. Okay, so let's go and now move on to our next graph. Our next graph that we're going to look at, our next piecewise function, or the piece of this function, is this highlighted in blue. And we can see that the domain, it's going to start at -1 closed, and it's going to go all the way to 0, x equals 0 closed. That's where it's going to be defined. So over here, I'm going to write out from -1 less than or equal to x less than or equal to 0. That's what I just drew. This is showing that highlight right here, domain-wise. All right. So now, let's move on to our last graph. Our last graph is this. It looks like an x-squared graph from that previous video that I recorded. And it's going to be greater than, so you're saying at x is equal to 0, and then all the way to the right because of that arrow, okay? That's the domain that you're describing. And we're going to write that as the following. We're going to say, you could do it 2 ways. You could say 0 is less than, because it's open, x, which is less than infinity. And we talked about this in class. We don't have to write that out. So we could just write x is less than, 0 is less than x, or x's that are greater than 0. And I like that one best. So x's that are greater than 0. Okay. So now, let's put this arrow back here, back on. All right. So now let's look at the functions. Since we're doing this by hand, and again, we'll be able to check with Desmos in the graphing calculator, let's work with this first function. Okay, so the thing that I want you to concentrate on are, look at where these corners meet up. Where does it hit corners at? And you can see that the rise is up 2 over 1, up 2 over 1, up 2 over 1. So the slope is 2. And it is a line, so we know it's going to be something like mx plus b. So far we have 2x plus, and we need that b value. Okay, so the slope that we just showed, that rise over run of 2, has been placed where m is at. Now I need to find where does it hit the y-axis. So if I were to keep going this up 2 over 1, so up 2 over 1, it would have, had it kept going on forever, it would have hit it at 3. So we're going to put that the y-intercept, where it hits that y-axis, would have been at 3. Okay? So we just found what our equation is going to be. It's going to be 2x plus 3. And we're done. We don't have to do anything else because this is saying this line right here. And what we did first, which was the domain, it restricted it to where basically that cropping analogy, we took off everything except for x's that are between -5 and -1, where it's including -5 but not including -1, which of course is what you have right here. Okay, so now let's go to the next one. So let me erase. The next one is also going to be a line. Okay, you see it as a line, y equals mx plus b. And just so you know, if it's a diagonal line either going up or down, it's going to be this. If it's a horizontal line that's just left and right horizontal, it's going to be y equals some kind of number. So it'll be some number there. Okay? And if it's a vertical line, it will be some kind of x equals a number. Okay? So if it has just y, it's horizontal. If it has just x, it's vertical. But if it has both the x and the y, it's going to be a diagonal line. Okay. So these first two pieces on this graph tell us that it's going to be a diagonal line. So let's go ahead and start with this second piece. I know it's going to have a y equals mx plus b. And this time they gave us the b. It's 1. So we'll say y is equal to mx plus 1. We know that. Now we have to do what we did on the other example of rise over run. This time from, again, corners to corners. You're going to go down 1, 2, and 3. So you went down 3 and to the right 1. That means a -3 because it's down. And a positive 1 because it's to the right gives us a -3 slope. So this would be -3x plus 1. This is our equation that we're going to put right here. We've already taken care of the domain, so we don't have to go back to that. Just real quick, the way I notated this, if it was up 3 to the right 1, it would have been plus 3, plus 3. If it was up 3 to the left 1, it would have been up 3 and to the left 1. So a -1 on that. And last but not least, if it would have been down 3 and to the left 1, it would have been down is negative and to the left is negative, which would simplify to a positive 3. I just wanted to give you just little quick tidbits as far as how you could interpret that so that you could get your positives and negatives correct on those slopes. Okay. Now, our last piece looks like this parabola, this quadratic, this new function that we've been talking about that's called x squared. Okay? And x squared on this one looks like, because remember we graphed x squared before, and it's a graph that you're going to get very familiar with this year, and it defaults at that origin, 0, 0. This one looks like it's been shifted down 2 units. Okay? So you're going to have to get a little creative with this, and you're going to see with Desmos or with the graphing calculator, because you could use a graphing calculator, it looks like it's shifted down 2 units. So it might look like this, or it might look like this, You know what I mean? You're going to have to play around with it just a little bit to make sure that it lines up with that picture that you have. Okay? So, after playing around with that graphing calculator, you're going to notice that it comes to this x squared minus 2. Okay? Now, I would say don't just rely on Desmos for these. I want you to play around with the calculator because you're not going to have Desmos again on tests and quizzes. Okay? So let's go ahead and go to the calculator, and what we're going to do is we're going to check our answers to see, does this all work out? Okay? All right, so let's do this first one of 2x plus 3. Okay? First of all, this graph that you see right now was from a previous problem. So to get in good habit, I'll show you in this video. We'll press delete 3 times. It'll prompt us to say, are you sure you want to delete? We'll say yes. Okay? So let me see if it'll let me highlight. Real quick. Maybe not. Okay, no worries. So what we're going to do is we're going to graph the first one. So we'll press tab, and we're going to do 2x plus 3. Okay? And when I graph it, you see that there's the line. Again, I can't restrict this graph on the TI Inspire the way I did on Desmos, but at least I know that that line going up looks pretty close to the line that we had on our graph. Okay? So there's that one, and there's that one. Okay, so the next equation that we were working with was in fact negative 3x plus 1. So we'll go to our graphing calculator, we'll press tab, and we see that it's our second function because it says f2. Let me erase this so that you can see it. And we're going to put negative 3x plus 1. And there's that graph. Okay? And again, the way this is shown, remember it was restricted. Let me go ahead and highlight it so that you would see what exactly would be used. So negative 5 all the way to negative 1, you would only see that part. The next one is negative 1 all the way to 0. You would see close at negative 1, that's x equals negative 1, all the way to x is equal to 0, and it would be shaded in between. Okay, so you have this first one is open to the left, the second one is closed, closed, filled in the middle. And then the last one was x squared minus 2. So we'll press tab, x squared minus 2, we'll press enter, and sure enough, that's the entire graph. And you see how it's shifted 2 units down, and it's going to be where it's greater than 0. So at x is equal to 0, we're going to have an open gap, and we're going to shade everything to the right. And this right here, what's in gray, is what we had on our graph. Now I know that's a little bit difficult to see because it doesn't restrict the domain, but as you're learning this, if you need to, only to check, you're more than welcome to go to Desmos and plug these in. Okay? But again, this shouldn't replace the learning, it's only checking your answers. Okay? So let's go ahead and see if Desmos is something close to what we came up with on that graphing calculator. Alright. We'll have 2x plus 3. We'll restrict it when we go back. We'll have negative, so the negative 3x plus 1. And then we'll restrict it when I go back to my computer. And then we'll have x squared, and it's going to be minus 2. Alright, so now let me go back to the graph, back to my computer, and I'm going to domain restrict this with those braces symbols. Here we go. Alright, so the first one, we'll press space, shift bracket. Again, this bracket is the key that's to the right of the letter P. And we're going to say from negative 5 less than or equal to, because it's filled in, all the way, so less than or equal to x, less than negative 1. And sure enough, you see that that's the only piece that was drawn. The next one is going to be from negative 1 less than or equal to x less than or equal to 0, close the brakes. And last but not least, our last piece of the piecewise function is going to be x's that are greater than 0. Close the brakes. And you see all of this graph looks like our shaded region. Now I know it's a little bit off because the size obviously of the graphing calculator is a little bit different, but basically it would line up pretty well as far as showing what that would be. If I were to enlarge it and kind of shift stuff around, it's still going to fit as far as what that graph would look like proportionally. Alright guys, now you have an example of how to do this by hand. I showed you how to also use the calculator to help and also to check your answer. And last but not least, I showed you how to use Desmos to check them when you're at home.